All right, ladies and gentlemen, we're going to be multiplying some radicals. So let's see what we have here. First of all, we're going to talk about the process. So we can multiply radicals if they have the same index. Remember, index is the number that you see here. If there is not a number, so if there's not a number, the index is 2. Okay, so if there's no number, the index is 2. So these are the steps, very simple. We multiply the numbers outside, then we multiply the numbers inside, and then simplify. So this is why simplifying comes in handy. So again, this right here is your index, so that's what we have to focus on. So this right here, a square root times a cube root, is not possible. All right, so here we go. We're going to start by multiplying the outside. In this case, we do not have any values on the outside. So then we're going to multiply on the inside. 3 times 3 is 9, so we have the square root of 9. Hoping you realize that this is a perfect square, so the square root of 9 is 3. So that is as simplified as we can get that. And I want to talk about this. Remember, prime factorization would be to get it down to 3 times 3. With an index of 2, we can circle a 3, which is where that comes from. Okay? For our next one, we're going to continue that process. We're going to multiply the values on the outside first. So 2 times 4 is 8. So that's our outside value. Then inside, we get 180. So this is going to be a little bit tricky because that value is so big, but it's okay. We got this. So I'm actually going to stretch this out. So 8 is going to hang out front, and I'm going to stretch it out here. So this will be 5 times 2 times 2 times 3 times 3. My index is 2. That 8 is not an index. That 8 is like a coefficient. It's hanging out front. I'm going to circle groups or pairs of 2 because that's my index. So these are the values I'm able to take out. So then I would have 8 times 2 times 3 because I was able to circle each of those. And then times the square root of 5. So then from here, all we have to do is clean it up a little bit and multiply 8 times 2. 8 times 2 times 3 is not 20,000. I don't know what I just did there. 8 times 2 times 3. I guess I could have done that a different way. So 48 times the square root of 5 gets us what we need. So essentially, whatever is under that radical should be prime and or not have any factors that are perfect squares. All right, so here we have 3 times 3 and then times the square root of 6. So in this case, we're just going to multiply the numbers that are outside the radical. So this will be 9 times the square root of 6. Now, 6 does have 2 factors of 2 and 3, but our index is a 2. So I'm not able to circle any pairs here. So then it's just going to stay 9 times the square root of 6. Okay? Now for this next one, we have a couple of things going on. We have 2 sets of multiplication, like we're multiplying quite a bit. So I'm going to focus here on this first one, and I'm going to multiply this guy. So 3 times 3 is 9, so this will be 9 times the square root of 3. Now the second piece here is 3 times 4, which would be 12 times the square root of 4. So now moving along, now we're going to multiply again the numbers that are on the outside. So 9 times 12 is 108, and then 3 times 4 is 12. So 108 is going to hang out outside. Let's go ahead and do our prime factors of 12, which would be 2 times 2 times 3. So I'm actually able to pull out a 2. When I do that, I have 108 times 2 times the square root of 3. So 108 times 2 would be 216 times the square root of 3. Even though the number got a little bit large, it's okay because it looks a little more simple on its own. All right, so let's say you've multiplied and this is what you're left with. Let's go ahead and practice a little more simplifying at this point. So I'm going to break this down. I'm going to spread this out or expand it out. So this would be 3 times 3 times 7. Times t times t times t times t. So my index is a 2, so I can circle a pair of 3's, a pair of t's, and another pair of t's. So I'm going to take out that 3. I'm going to take out a t, another t, and then the square root of 7 is left over. So when I clean this up here, this would be 3t squared times the square root of 7. Okay? Now for the next one, I'm going to go ahead and expand that guy out, which would be 2 times 2 times 2 times 2 times 3, and then times n, n, and n. So I'm able to circle a couple of pairs here, or a few pairs. So as I pull those values out, I'm left with 4n times the square root of 3n.